So now that we know that heat always transfers from hot to cold, let's talk about something that a lot of people say wrong. And I actually said it wrong until I started teaching sixth grade and learned about this. So when we have something hot, we always say, oh, I need to cool it down. But that is not actually what is happening. So, an example is that my kids love mac and cheese. So, to make mac and cheese, it's a hot dish. But then my kids hate things that are hot, like, oh, it's hot, I can't eat it, right? So, being the smart mom that I am, I put some vegetables in their mac and cheese so that they are getting their veggies in at the same time. But I put in frozen vegetables. So I put these frozen peas in my kids' mac and cheese. And I would always say, and everybody always says, oh, I'm going to put this frozen thing in here to cool this down. But that is not what is happening. What is happening is the hot mac and cheese. So I pour these peas in here and I mix these all up, right? So they're all mixed together. And the hot mac and cheese has more kinetic energy. It has more energy to give. These are moving very slowly, right? They're just vibrating little molecules. They have very low kinetic energy. They're barely moving. And so they don't really have energy to give. So what is happening is the hot mac and cheese, it's giving its energy to the frozen peas. And while it's giving its energy away, that means that they're slowing down and they're cooling down because now they're giving that energy away. So now while these peas were frozen, they're receiving energy. They're getting energy from the hot mac and cheese. And so that means these are actually going up in kinetic energy. So these are getting more heat energy. Our mac and cheese is getting less heat energy. So the mac and cheese is going down in temperature, which means its kinetic energy is going down because it had a lot. So it gave it away. It had extra to spare. And the frozen peas are getting that energy. And they're going to keep doing that until they balance and reach something that we call thermal equilibrium. Thermal equilibrium. So thermal means heat. So their heat reaches an equal balance. When things are in equilibrium, that means they are balanced. So the mac and cheese gives the heat away. So the peas are not really cooling the mac and cheese down. The mac and cheese is heating the peas up. So next time your parents are like, here's another example. So you get this nice cup of hot chocolate. Let me grab something here. So you get this cup of hot chocolate, and oh my goodness, this is going to look so delicious. Okay, so we have this nice, warm, steaming cup of hot chocolate. And you take a little sip, and what do you know? Oh man, your mouth gets burned. So you want to lower that heat energy. It's got too much heat right now. So what you're going to do is you choose to put ice in there. And you might say something like, oh, I'm cooling my hot chocolate down. Or your parents might say, here, put this ice in here, cool it down. And you're going to say to them, no, what's actually happening is the hot chocolate is giving the ice its energy. So the hot chocolate's temperature is lowering, which means the ice's temperature is raising until they meet thermal equilibrium. And then your hot chocolate is at a great temperature for you to just drink and enjoy. So heat transfer always, always, always goes from the hotter thing to the colder thing. Always, because this has more kinetic energy. It can give that energy away. If you put your warm up your hands and touch like a cold desk, your hand is going to give the energy to the desk. If you eat a piece of pizza that's very piping hot, your tongue is colder, and that pizza is going to give that energy to your tongue and burn it. The hot item gives its energy to the colder item.